So just as a brief kind of introduction to myself and to Capabilities Limited, we're a specialized security consultancy. We're largely focused on CHERI and Morello, applied research tasks, and commercial exploitation of those technologies. I think we do amazing work. Personally, I'm involved in porting Chromium and V8. My colleague, Heshem, who's in the audience, is doing some amazing work porting SEL4. And some of that work you can see on the posters at the side if you're interested. So in the distant past of 1.5 weeks ago, when somebody first mentioned the idea of giving a talk, the talk was originally going to be like a worked example of porting software to CHERI. And that could be a really interesting talk, but it's really detailed. You have to know something about the software, and you have to also care about the software. So instead of that, I've tried to bring it up a bit higher level and just talk about porting in general and just give a more kind of introductory sense of what's involved in porting software to CHERI. So I come from not a unique perspective, but I come from a perspective of being somebody who didn't develop the solution. So I'm just a consumer of CHERI and Morello. I port quite a lot of software to it. And I tried to think about what I might have wanted to hear like a couple of years ago. So hopefully, by the end of the talk, we're going to at least be able to shed a little bit of light on these 3 questions. What am I even talking about? What does it mean to port software to CHERI? What kind of things do I have to do? How much work is that? And once I've gone through all of that process, what do I get out of it? What is even achieved? So I started with this definition that I lifted from Wikipedia, both because that was an easy thing to do on a Sunday afternoon. But I also really like this idea of porting being about carrying things from one place to another. We're lifting it up from one place, and we're putting it in another place. And here we're talking about an execution environment. And that could mean like different things. It could mean porting from different operating systems, could mean porting between different languages. But the essence that I'm trying to get across is that whatever porting is in CHERI, it means taking it from one execution environment and putting it into this new CHERI-enabled execution environment. Slide's a bit weird. Porting could be driven by lots of different motivations. It could be like, I want to use the new cool programming languages that are being used in the Bay Area. But here we're mainly talking about porting for the purposes of achieving some security goal. And one of the ways we could achieve that security goal is by taking our software and porting it to a different memory-safe language like Rust. So this is an export of Google Docs that's gone wrong. But we could port it to Rust, and that's a completely valid thing to do. But as Robert and other people talked about, the issue there is the scale of software that sits in the world. 10 billion lines of C and C++. So here, when we're talking about porting to CHERI, we're definitely talking about porting legacy C and C++ code bases and giving them security properties that they couldn't otherwise get without complete rework. So whatever this porting is, it's got some design goals. And that design goals are as follows. Like, I'm a C programmer. I first learned C programming in 1992, which was over 30 years ago. So I should be reasonably able to do this porting effort, and it shouldn't be a huge amount of effort for me. It should be fairly minimal. Practically, compiler infrastructure should be able to do that job of compiling this code with very limited changes. We can't rip up the whole world of how compilers work. And once we've done it all, we should get some high level of mitigation of exploitable memory safety vulnerabilities. So saying that I was going to go fairly high level, I've immediately wanted to dive down into a little bit of detail. If you're not technical, or if you haven't done software engineering for the last several decades, put your seatbelt on, don't move about the cabin. The turbulence will settle fairly shortly. So in a conventional architecture, pointers are represented with simple machine word integer values. So I had 2 bits of code. I ran it in an online compiler. One was incrementing an integer. The other one was incrementing a pointer. The details on the side, again, it's slightly gone wrong in the export. what we're actually supposed to see is the two add lines. So if we look at the adds, they were supposed to be highlighted by the boxes, but inconveniently they're not. The add instruction generated for incrementing an integer and incrementing a pointer are exactly the same thing. So if you've got a pointer, you want to multiply it by 57, you want to add 100 million to it, that's your problem. It's just an integer. That might not go so well for you, so don't do that. So in Robert's introductory talk and in other talks, we've got this idea that a capability is something more than an integer value. It's an integer value, and it's got associated metadata, it's got bounds, it's got permissions, and all of those kind of things. So in this case, this code, I compiled it using the Morello compiler. The integer addition, again, it generates the same instruction as before. It generates an add of these X registers. There's just 64-bit registers. But down in the increment pointer, the add now, which again is supposed to be highlighted, does adds on these values C0 and C0 value 1. So suddenly we get capabilities in the add. And if we looked at the decoding of that instruction, it's a completely different instruction. And it kind of has to be, because it has to be an instruction which can do all of this enforcement of the security properties that we want, making sure that bounds are respected, or making sure that when we manipulate capabilities, that permissions are respected, and all of that kind of stuff. So our basic concept is that in the porting activity, all C language pointers are represented with capabilities instead of words. And again, I've made a career knowing absolutely nothing about compilers. So there's some magic process that the compiler manages. It has to have a distinct notion of what is an integer and what is a pointer, so that at the outset, when it does the code generation, it can generate the correct instruction. Okay, let's move on from some of the detail. So the key point I wanted to get from the last slide is you don't have to do anything. I didn't do anything. I just read that code and I compiled it, and what I got out at the bottom was different instructions. So that's all great, but there are some cases where that doesn't work, and this is an example of that. It's from the Chromium source code. It's a data type, and I have this int64 value. So I have a value which it says is an integer. But when you look at how that value is used, it's actually used to store a pointer value. And on a conventional architecture, that completely works, because on the earlier slides, we saw that a pointer is just an integer. So this is absolutely fine. It's in some kind of way incorrect usage of this type, but it will totally work. But it doesn't work on CHERI, because I need to maintain that distinction between what is an integer value and what is a pointer value. And how I do that is by using types. And in particular, I use this int pointer t type, and I say, this value is now an int pointer t. And an int pointer t is a type specified in the C standards that says it's at least as wide as a pointer value, and here it's at least as wide as a capability value. And the compiler can use that type information to work out what instruction should be generated for it. So more generally, what you kind of want to know as a programmer is, what can I rely on? What will the compiler just do for me? And what do I have to do? Here there was something that I had to do to make it work for me and to make well-defined CHERI, C, and C++. Now the answer to that in terms of like formal semantics is a little bit complicated, and that's because you have compiler optimizations. So compilers can do all sorts of like magical and funky things, and they can optimize things, and they can make things not happen. So that's all like slightly complicated, and you can read about that in an academic paper, that's fine. But in practice, from like a practitioner level, what you're actually required to do is mainly a straightforward set of porting tasks. And they're outlined in this guide, the C++ Programmer's Guide. And for most types of software, you can go through the guide, you can read its advice, and one of the pieces of advice will be about use of types. You correct the type, you recompile it, and it's all good. So largely, we're talking about a very, very straightforward process. So for the rest of the questions, I wanted to ground that in a more concrete example. So I'm going to talk a little bit about some work that we did on porting web service stacks, and particularly the Nginx web server. So if you're not familiar, a web server, you make a request, it answers the request, and you get your web page or whatever you're requesting. And this is a battle-hardened piece of software. It's deployed in the real world. It's the most commonly deployed web server in the world. And in terms of scale, we're talking fairly small piece of software, 150,000 lines of C code. So how much effort is it to port something like Nginx to CHERI? It's actually a very small amount of effort. We showed 0.1% line of code changes, and that's pretty consistent with figures that other people have talked about and other studies have shown, largely in that 0.1, 0.25%. But that comes with a set of limitations. We think our port is pretty mature. We think it works pretty well. But in reality, we're talking about a technology that detects problems at runtime. So it's only as good as the test coverage that you have and the testing that you've done on it. And there could be problems within the port that have not yet been realized. And there were some technical things around protections that we didn't do as part of that port. But they wouldn't significantly change the effort here, I don't think. More generally, we think of there being a sliding scale of effort. Some things are no effort at all. You just recompile them and it's all done. Some things like the web service stack we see in this kind of minimal small effort range. And the vast majority of software is going to be somewhere in this range of no effort, minimal effort. And then on the far right, we've got the much more disruptive things like language runtimes, things like operating system kernels. So there's all sorts of factors, both intrinsic and extrinsic, that affect how easy it is to port pieces of software. If they use modern C and C++, they use types correctly, then things tend to go pretty well. If they're very high-level pieces of software applications, again, porting tends to be easier than low-level software, which tends to be more involved in manipulation of low-level memory. If they have their own internal memory models like V8, that's a bit of a worry. That's going to be a bit more disruptive. But still, even at the high end, we're only talking about 1-2% lines of code change. So the next question. Okay, I've done all that stuff. I understood what I had to do. I've done it. I've ported it all. What do I get out of it? So what we did is we did an analytical study looking at historic vulnerabilities in Nginx. And we started that by having a look at the common weakness enumeration assigned to advisories. And what we see in Nginx is that a big number of those are about buffer overflows. They're overwrites, overreads. And the next most significant problem we see there is this thing of resource exhaustion. But that gives us a good feeling that CHERI is going to be a good technology because it's going to mitigate a lot of those kind of buffer overwrites and overreads. And that's what we see in practice. We see kind of consistent with the figures that other people have mentioned today. We see around a 50% mitigation rate with CHERI on the historical Nginx problems, vulnerabilities. And we also did some analysis of what we think the mitigation rate would be with experimental compartmentalization drawn at various boundaries. And we can raise the mitigation rate up from 46% just with memory safety up to around 60%. Okay, so in summary, what does it mean to port software to CHERI? It basically means porting to CHERI C and C++. You follow a set of largely known and understood patterns. How much effort does that involve? We're pretty confident now that that is in this kind of 0.1 to 0.25% range, fairly short. And what you get this deterministic mitigation of 60 to 70% of memory safety issues that are present. And that's it. Thank you.